What if we could survive on Venus? What if, using the most advanced technology humanity can create, we establish the first base, not on the surface, but floating in the clouds, 50 kilometers above hell itself? Over the next 100 days, you'll witness a catastrophic acid breach that dissolves the habitat's outer shell. A pressure failure that nearly crushes the crew alive. The discovery of something moving in the sulfuric acid clouds. And deep in Venus's atmosphere, a mystery that could rewrite everything we know about life in the universe. The clock starts now. Day 0. After 4 months traveling from Earth, the spacecraft hits Venus's atmosphere at 40,000 km/h. But this isn't like Mars or the Moon. Venus has an atmosphere, a thick, suffocating carbon dioxide blanket that extends 250 kilometers above the surface. The heat shield glows white-hot as friction bills. Temperature outside the capsule 1,200 degrees Celsius. Inside, the crew is pinned to their seats by deceleration forces. 8 gs, 9 gs. Breathing becomes a struggle. Vision tunnels. This is 12 minutes of wondering if the heat shield will fail and vaporize you instantly. But the real challenge comes next. Controlled descent through the acid clouds. At 70 kilometers altitude, parachutes deploy. The capsule slows, drifting through layers of sulfuric acid haze. The clouds here are 80% sulfuric acid, the same chemical used to dissolve metal in car batteries. One breach, one seal failure, and the acid gets in. The crew holds their breath. Not literally, but mentally. Every alarm, every vibration feels like the end. And then at 50 kilometers altitude, the capsule stabilizes. They've reached the habitable zone. Here's the insane part. At 50 to 60 kilometers above Venus's surface, the conditions are shockingly Earth-like. Temperature 20 to 30 degrees Celsius, comfortable room temperature. Atmospheric pressure 1 bar, same as Earth's sea level. You could walk outside in a breathing mask. No pressure suit required. Gravity 0.9 g, almost identical to Earth. Your body wouldn't waste away like on Mars or the Moon. This is the Goldilocks zone. Not on the ground, not in space, but floating in the clouds. The habitat pre-deployed months earlier is a series of inflatable modules filled with breathable air, nitrogen, and oxygen. Since Venus's atmosphere is pure carbon dioxide, breathable air is actually lighter than the surrounding atmosphere, which means the habitat floats, suspended in the Venusian sky, drifting with the winds. The crew transfers from the descent capsule to the habitat via a pressurized tunnel. Airlock seal. Systems activate. They've arrived. But this isn't standing on solid ground. This is living inside a bubble floating above the most hostile planet in the solar system, held aloft by nothing but physics and hope. Commander Zhao approaches the observation window, looks out. The view is unlike anything ever witnessed by human eyes. Above, yellow-orange haze stretching endlessly. The sulfuric acid clouds glow faintly from scattered sunlight. Below, nothing, just deeper shades of orange and brown, eventually fading into impenetrable darkness. The surface is down there somewhere, hidden beneath 50 kilometers of crushing atmosphere. And the horizon curves sharply. Venus is smaller than Earth. And at this altitude, the curvature is pronounced. The world feels enclosed. But the strangest part, the wind. Venus's atmosphere rotates 60 times faster than the planet itself. A phenomenon called superrotation. At this altitude, winds scream past at 350 km/h. The habitat drifts with them, circling the entire planet every 4 Earth days. You're not staying in one place. You're flying constantly around an alien world. Commander Zhao whispers, "We're not astronauts anymore. We're aeronauts. Welcome to the age of atmospheric colonization." The first week is about understanding the environment. And the environment is trying to kill you. The acid. The clouds aren't water vapor. They're sulfuric acid aerosols. Touch them and your skin blisters. Breathe them and your lungs dissolve. The habitat's outer shell is made of acid-resistant polymers and Teflon coatings. But even Teflon degrades slowly, inevitably. Every day, the crew inspects the exterior via drones, looking for discoloration, pitting, weakness. Because one breach means acid flooding the airlocks. And acid doesn't just burn, it corrodes, dissolves, destroys. Water. There is none. Venus has almost no water. The crew must recycle every drop with 99.9% efficiency. Urine, sweat, condensation, even the moisture in their breath. They get 2L per day for everything. Oxygen generated by splitting CO2 from the Venusian atmosphere using solid oxide electrolysis. The process is energy-intensive, requiring constant power from solar panels floating above the habitat. Food. Freeze-dried rations calculated to last 500 days. But there's a problem. The acid atmosphere corrodes storage seals. Food containers develop micro-leaks. Moisture gets in. Spoilage begins. Biologist Kim discovers it on day 5. 10% of their rations are compromised. They recalculate. With reduced supplies, they have 450 days, maybe. Margin of error, 0. Day 4, 1,800 hours. A pressure fluctuation. The habitat is drifting into a lower altitude zone where atmospheric pressure increases from 1 bar to 1.2 bar, then 1.5 bar. The habitat modules designed for 1 bar differential start compressing. Seams strain, joints creak. Engineer Novak races to the control panel. They need to vent ballast, release weight to climb back to 50 kilometers altitude. But there's a problem. The ballast is water. Vented and they lose their precious reserves. Commander Xiao makes the call. Vent 50L. We climb or we die. The water dumps. The habitat rises and pressure stabilizes at 1 bar. They've survived, but they just lost 50L of water. 2 weeks of rations. The crew sits in silence doing the math. Every decision here is a trade-off between survival now and survival later. Day 7, night falls. Not the 14-day cycles of the moon, but Venus's strange daylight rhythm. 58 Earth days of sunlight, then 58 days of darkness. But the crew isn't in darkness yet. They're drifting through a storm system. Venusian lightning, not from water clouds, from sulfuric acid and volcanic ash. The strikes are more frequent than Earth's and far more powerful. A bolt arcs near the habitat. The electromagnetic pulse scrambles electronics. Screens flicker. Systems reboot. Medical Officer Park checks the instruments. We just lost primary navigation. We don't know exactly where we are anymore. They're floating blind, drifting with 350 km/h wind somewhere above the most hostile surface in the solar system, and they have no idea where they'll end up. By week 2, routines form, but they're different from Moon or Mars because nothing here is stable. 6 a.m. wake, check altitude, check pressure, and heck, drift speed. The habitat is always moving. 7 a.m. breakfast ration. Reconstituted protein, vitamin supplements, acidified water. It tastes faintly metallic from the filtration process. 8 a.m. exterior inspection. Deploy drones to scan the outer shell for acid damage. Repair any corrosion with polymer patches. 12 p.m. atmospheric sampling. This is the mission's purpose. Study Venus's atmosphere, chemistry, wind patterns, and lightning. The mysterious UV absorber in the clouds. 16 p.m. habitat maintenance. Air scrubbers. Pressure regulators. Solar panel cleaning. Acid mist coats everything. 19 p.m. dinner. Rations again. Someone jokes about opening a restaurant. No one laughs. 21 p.m. personal time. Video messages to Earth. 6-minute delay each way. Conversations feel painfully slow. 10 o'clock p.m. sleep if you can. The habitat sways constantly in the wind. It feels like sleeping on a boat in a storm that never ends. But there's something beautiful about it, too. You're flying. Truly flying, suspended between hell and space. Day 12. The crew deploys the atmospheric probe, a reinforced drone designed to descend toward the surface and transmit data before the heat and pressure destroy it. The probe descends 40 kilometers, 30 kilometers, and then 20 kilometers. Temperature readings climb 150 degrees Celsius, 250 degrees Celsius, and 350 degrees Celsius. Pressure increases 10 bar, 30 bar, 60 bar. The camera feed shows layers of haze, lightning storms, and then something unexpected. At 35 kilometers altitude, the probe detects movement, not wind, not turbulence, something organized, shapes, dark patches moving against the wind. Biologist Kim stares at the screen. That's not debris. The probe descends further. The shapes disappear into the haze. At 10 kilometers altitude, pressure 50 bar, temperature 430 degrees Celsius, the probe signal cuts out, crushed and melted. But the crew has the footage and the question, what were those shapes? Day 22. A micropuncture in Module CS outer shell. A droplet of sulfuric acid has penetrated the Teflon coating. The acid eats through the secondary layer, then the tertiary. It's dissolving the habitat from the outside in. Engineer Novak suits up. Acid-resistant EVA suit, full face shield, steps into the airlock, opens the outer door. The wind hits like a freight train. 350 km/h gusts. She clips her tether and crawls along the exterior, fighting the wind, searching for the breach. She finds it, a tiny hole. Acid seeping through, corroding everything it touches. She applies a polymer patch, presses hard. The acid dissolves the edges of the patch. She applies another and another. Finally, the seal holds. She retreats inside, collapses, shaking. Commander Xiao runs diagnostics. The outer shell has 200 micro-pits from acid exposure. We need to recoat the entire habitat. They have polymer reserves for maybe 3 reco. After that, the acid wins. The crew realizes this isn't a 500-day mission. It's a race against corrosion. By day 30, the crew has drifted 40,000 kilometers around Venus. They've passed over Ishtar Terra, Maxwell Mantes, the highest mountain on Venus, and vast volcanic plains hidden beneath the clouds. Using radar, they map the surface below, and they discover something extraordinary. Active volcanism, heat signatures, fresh lava flows. Venus is geologically alive, but there's something else. An anomaly. Day 45. The crew is analyzing atmospheric samples when biologist Kim notices something in the sulfuric acid aerosols, organic molecules, complex carbon chains, phosphine gas. On Earth, phosphine is produced almost exclusively by life, microbes in swamps, bacteria in animal guts. On Venus, there's no known abiotic process that produces phosphine in these concentrations. Kim runs the analysis 3 times. Same result. She looks at the crew. Either Venus has chemistry we don't understand, or there's something living in these clouds. The crew sits in stunned silence. Life on Venus? Not on the surface, but here in the clouds. Floating microbes adapted to sulfuric acid surviving on solar energy in atmospheric chemistry. It's not confirmed. It's not proven, but it's possible. Day 50. Biologist Kim sets up the greenhouse experiment. Genetically engineered algae designed to survive acidic conditions. She introduces the algae to a controlled sample of Venian atmosphere, CO2, trace sulfur compounds, sulfuric acid mist. Days pass, nothing. Day 60, growth. The algae are surviving, photosynthesizing, converting CO2 to oxygen. It's proof that life, engineered life, can exist here. The crew gathers around the greenhouse pod, watching green algae bloom in a container floating above hell. Someone whispers, "We can terraform this." Not the surface, but the clouds. Turn Venus's sky into a breathable biosphere. It would take centuries, maybe millennia, but it's possible. By day 70, the isolation becomes unbearable. There's no solid ground, no horizon that stays still, no daylight cycle that makes sense. The habitat drifts endlessly, and you drift with it. Vertigo becomes chronic. Your brain can't process floating indefinitely. Some crew members develop motion sickness that never goes away. An Earth. It's visible sometimes, a bright star in the orange sky. But messages take 6 minutes each way. Conversations feel hollow. Engineer Novak stops sleeping, starts hearing things, whispers in the air circulation, shadows moving in the acid clouds. Medical Officer Park diagnoses it. Sensory deprivation psychosis. The brain, starved of normal input, starts inventing stimuli. They're not just isolated. They're losing touch with reality. Day 75. Commander Zhao wants to return to the original altitude, 50 kilometers. Biologist Kim wants to descend to 40 kilometers to study the mysterious moving shapes. We're scientists, Kim shouts. We came here to discover. We came here to survive. Zhou fires back. The argument escalates. In the confined habitat, there's nowhere to go. No escape. Engineer Novak throws a tool. It bounces off the wall in the low gravity. They're not just fighting about the mission. They're fighting because they're trapped, stressed, and afraid. Venus's gravity 0.9 g is almost Earth-like, but almost isn't enough. Muscle atrophy slows but doesn't stop. Bone density decreases. The crew exercises daily, but the lack of proper resistance equipment means they're still deteriorating. Medical Officer Park develops chronic joint pain. His spine is compressing from months of limited movement in the cramped habitat. And the acid exposure is cumulative. Despite precautions, trace amounts seep through seals causing respiratory irritation. Everyone has a persistent cough. They're dying slowly and they know it. Day 77. Venus's long night begins. The sun disappears for 58 Earth days. Solar power drops to zero. The habitat switches to backup fuel cells. Limited reserves designed to last only 30 days. But there's a problem. The fuel cells were damaged during the acid breach on day 22. They're operating at 60% efficiency. The math is brutal. They have 18 days of power, not 58. They're going to run out of power in the middle of the Venusian night, floating blind with no way to recharge. Commander Xiao initiates emergency protocols. Shut down all non-essential systems. No lights except for emergencies. No heating except survival minimum. Minimal air circulation. Temperature inside the habitat drops to 5 degrees Celsius. The crew huddles together, wearing every layer they have. Oxygen generation slows. CO2 builds up. They ration breathable air, wearing masks to conserve supply. And in the darkness, floating through the acid clouds, they wait. Day 78. A massive atmospheric storm system engulfs the habitat. Lightning strikes every few seconds. Electromagnetic pulses fry backup electronics. The habitat loses altitude control. They're sinking. 48 kilometers, 45 kilometers, then 42 kilometers, pressure increases. Temperature rises. If they drop below 40 kilometers, the pressure will crush them. Engineer Novak manually vents ballast, their last water reserves, 100 L, 200 L. The habitat stabilizes at 43 kilometers, but they've just dumped half their water. They're alive, barely, but now they're thirsty, cold, and running out of time. Day 82. After 9 days of darkness, the sun rises. Solar panels recharge. Power returns. Heat flows. Oxygen generation resumes. The crew emerges from their survival pods. Exhausted, dehydrated, but alive. Day 85. Biologist Kim implements a desperate plan. Condense water directly from Venus's atmosphere. Venus has trace water vapor. Only 20 parts per million, but it's there. She rigs a chemical scrubber that captures CO2 and extracts the trace water. It takes 72 hours to produce 1 liter. It's not enough, but it's something. Day 88. The crew gathers at the observation window. They've survived acid, pressure, darkness, and storms. Commander Xiao speaks quietly. Venus tried to kill us, and we're still here. For the first time in weeks, someone smiles. Day 93. The algae experiment is producing oxygen at measurable rates. Proof that Venus's clouds can support life. Day 96. The atmospheric probe detects them again. Dark organized shapes at 35 kilometers altitude. The crew analyzes the footage frame by frame. They're not debris, not turbulence. They're moving with purpose against the wind. Biologist Kim whispers, "We're not alone here." Day 98. Commander Zhao records a log. We came to Venus expecting hell. We found something stranger. A world where life might exist in the last place we'd look. Not on the ground, but in the sky. Day 100. The sensors detect a massive updraft forming beneath them. A volcanic eruption on the surface 50 kilometers below, sending a plume of ash and gas toward their altitude. And in that plume, thermal readings, chemical signatures. Something is rising from the depths.